kind of like thrown.
This is quite squeaky.
It's good. It's better that way.
Yeah, right. Hello? Yes, fantastic. My mic wasn't even on. It's fine. Okay, so is everyone sitting down? Roughly looks about right. Okay, so the way we're going to do this is if anyone was at the Q&A session last year, the entire thing was this. And so it's pretty much open season. There's going to be a really wide array of questions you can have, like from specific rack problems to wide theoretical questions. I've got a few which I'm going to ask to get things moving. Also, there's an issue online if you don't feel comfortable just putting your hand up. We should have mics somewhere. Could I what now? Oh, it's the issue number is 1367 on Reactive Cocoa repository. So if you want, you can just comment on there and I'll ask that question. But otherwise, you guys are more than welcome to. So we're going to start with the obvious one. Swift. It happened. That's it. Swift is good. How good is Swift?
Cool story, bro.
And is there a reactive Swift? What does it mean?
I think Justin wrote Reactive Swift last night in a
fit of rage,
stupor or something. Yeah, that exists probably.
He was thinking about it even if he didn't.
Yeah, he's been dreaming about it. Been dreaming the dreams. I mean, Swift is going to be pretty great for us. One of the problems with Reactive Cocoa as an effective being done in Objective-C is that you have this rack signal, but you don't actually know what's in the rack signal or what kinds of values you're going to get out of the signal. And so Swift will allow us to parameterize signals by the type that it's sending, and that's fantastic. The stuff that Jon Sterling was showing earlier is really interesting, but the downside to that in Objective-C is that it's just a whole lot of signals, and you lose all that type information. So we'll get to do much more interesting things and much more complex structures because we can now specify the types, and the compiler will help us out with that.
As far as game plan, I mean, based on the limited playing around we've done with it, Swift still seems very much a beta endeavor. There are a lot of things for which it fails to generate code or fails to compile that should work in theory. But once it's solidified a bit more, we can just have an open discussion about this. I'm thinking, since we're doing Rack 3.0 anyways, maybe Rack 3.0 can offer a Swift interface, and you can pass in your rack signals, and you can convert them back and forth to the Swift type. But this would be a great way to kind of just solve the backwards compatibility problem anyways, is offer the new interfaces of what we really want going forward in Swift, and then offer a way to convert back and forth between the Reactive Cocoa 2.x representation, which is just the rack signal class. So just like some functions to bridge back and forth, I think, would solve that problem mostly.
Yeah, I'd go ahead and write Rack 3 in Swift directly. I mean, none of the classes are meant to be subclassed anyway, so.
Yeah. My only comment to add would be that I saw some tweets saying something to the effect of, we don't need Reactive Cocoa because we have Swift now. But I think that tells something that people see, I think that people will be more comfortable with it because they're likening Reactive Cocoa and Swift. So I think the functional paradigm will help make Reactive Cocoa be sort of more familiar to people as they adapt.
Let's stay with that though, because there was some code which went up on screen or stage, whatever you want to call it, which looked like they were doing map operators and this, that, and the other. Like on face value, there's some pretty Reactive Cocoa looking stuff in there. What is still special about Rack?
I mean, those are just transforming collections. Like that doesn't give you any of the reacting to changes, doing asynchrony. It doesn't allow you to represent things like, button presses, network requests, all the good stuff that I was talking about.
Your favorite
before.
button press?
Yeah, yeah. I mean, it is like, in Ruby you have map and filter and stuff too, but I don't think anyone would argue that, normal Ruby code is very much like Reactive Cocoa or obsoletes Reactive Cocoa or the equivalent in Ruby. But yeah, it's a nice way to ease people in because I think it will increase familiarity.
Cool. We don't have to go down the line, by the way. And I also realized I didn't introduce anyone. I just expected you all to know.
Who are you people?
Yeah. these are collaborators on Rack. Do you want to introduce yourselves, or shall I just do it for you?
We can. I think we should introduce ourselves.
Can you
I don't
manage?
trust you at all. I'm Josh Abernathy. I may be the godfather of Reactive Cocoa.
That is terrifying.
And maybe Justin's foil. I wrote a lot of the original Reactive Cocoa stuff, and I still do a lot of maintenance. Justin does a lot of the, a lot of things, a lot of Justin things. Dream crushing.
A lot of rewriting Rack command.
A lot of making me cry. So that's my relationship, and I work here at GitHub.
I'm Justin Spahr-Summers, Spahr-Summers on Twitter or GitHub. I was recruited to GitHub by Josh Abernathy, but joined him working on Reactive Cocoa like several months in, and helped push out 1.0 and then 2.0.
And then destroy 3.0.
Yeah. But we've kind of collaborated closely since I the light bulb went off, and I was like, oh, this is great for everything. Yeah.
So I'm Uri Baghin, GitHub name Conoco, and I've been contributing to Reactive Cocoa for a couple of years now. I've mostly worked on the KVO bindings, both one-way and two-way bindings. By the way, don't use the two-way bindings. And that's it, really. I have black hair. I dyed my hair when I took my profile picture, so...
Uri's from Italy, too. I'm Dave Lee from Canada, since we're talking countries. Sorry. I got into Reactive Cocoa, I don't know, maybe a little over a year ago. Mentioning Ruby, that was kind of my gateway in. I was doing a bunch of Ruby Motion stuff at the time, and I wanted to get Reactive Cocoa running in Ruby Motion just to familiarize myself, and then I was pretty much hooked after that. Like Justin said, I realized you could use it for everything. It immediately clicked for me. So, and then I asked a lot of questions and probably asked stupid questions, but hey, I've enjoyed it, and here I am. So.
And your GitHub name is?
Oh, Castiglione.
Fuck, that's how you say it. Cool. I had to check. Okay, so next question, which does anyone in the audience want to ask something? If not, we have others. All right, fantastic. So I'm going to go to the issue thread where someone has just asked, man, I don't even want to try and pronounce everyone's usernames. This is going to go real bad. I'm going to guess Agath, something like that. Sorry, I just butchered it. And this is probably one for you, Dave. What's a Reactive Cocoa way to rackify delegate methods that require a return value, such as table view, cell for row index path, or the similar ones?
So when we use, we have signal for selector, drew a blank there, which I mentioned, but that can create a method for you, but it can't create a method that takes return type, or has a return type, return value. So in those cases, you have no choice but to implement the method yourself and have it return whatever value you want it to, and just focus on the return value, not on acting on things in it, and still use, once you've defined it, you can still use signal for selector, which hooks into the existing method and fires every time it gets called, just like a void delegate method would. And then off you are. There's no extra setup. Basically, just implement it. A lot of times, those methods, for UI table view, for example, returning a cell. I don't know if you would really need to hook into that using signal for selector, but some of the delegate methods that are just Boolean, should do this, should do that. In my experience, they're often just return yes, return no, or maybe check some value. But basically, they're very minimal. So.
And there's a good reason for this too. So I think the gist of the question is, can you define a method that returns a value using a signal? And the reason you can't, or can't in an understandable way anyways, is because that method needs to return something immediately. And if you have a signal type, when's the next value going to come? What's the return value of that method going to be? You could say, oh, well, maybe it should be the last thing that the signal sent, but then you run into some timing issues, or there are a million problems with that. So it's far easier to just let people return something synchronously, and then if you want to, you can store something in a property and like have a signal that binds to that property or what have you.
There's to consider, generally when Apple use delegates, they're conflating two different patterns together. One is the void return delegate methods are the observer pattern, whereas the non-void return are the delegate, as in you might want more objects to observe the void return ones, and that's what rack helps you to do, to observe. And as for the other type of use of delegates, you can just do it normally, yeah.
Cool, nice. Any from the audience?
Come on, someone step
I'm
up.
going to guilt trip you all pretty soon. No, it's cool. They're coming in on the issue thread. Another one, oh man, this is going to be, okay, how do I say this? It's not even hard. It doesn't look hard, but I'm panicking. I think it's Adrian Tufan. I think it's someone's name. I'm bad. Whoever you are, I'm really sorry. He asks, the enumerable/observable duality is present in Eric Meyer's reactive world for some time, or has been. Was there a particular reason not to use it in Reactive Cocoa? I'm presuming 2.0. Do you know if enumerable/observable concept is present in other implementations like Elm, which doesn't appear to originate from Mr. Meyer's work?
So there are two questions there. I'll answer those separately. First of all, the enumerable observable distinction does exist in Reactive Cocoa 2. Whatever. In the form of rack sequence and rack signal. Rack sequence is basically enumerable. The reason that is not as interesting to me as the stuff I presented today is because it doesn't deal with asynchrony. It's not the promise-based enumeration like I was talking about, which is really the direction I think we should go. And that's what I got out of Eric Meyer's talk, which is like, this is a new thing that we're adding. It does asynchronous stuff too, and that's when it really clicked for me. And I was like, oh, this is actually valuable. And then the second question. Sorry, can you refresh me the second part?
Oh, yeah. So the second one is, do you know if the enumerable/observable concept is present in other implementations, like Elm, which doesn't appear to originate from Mr. Meyer's work?
Yeah, so not really. And the reason for that is because if you remember the type signatures from my talk where it was like the empty parentheses everywhere, those represent side effects. And in languages like Elm, which is, for anyone that doesn't know, it's a functional reactive programming language that compiles down to JavaScript and is completely pure and stateless. But the reason it doesn't have this enumerable observable thing is for that reason. It's stateless. You don't have side effects. Basically, you just chain together all these operators and things happen, but you can't ever say like, oh, when this happens, change the value of this. Instead, you're saying the value of this is derived from all these other things. So it's not really applicable.
It's fair.
Yes, this duality is mostly important for when dealing with side effects and the order and ways things are evaluated. Many other RX-related languages try to be more purely functional and not have the user care about evaluation and things like that at all. So there isn't really any useful duality there.
Any more to it? I love whoever just asked this. Rui A.A. Perez, I think I nailed that. Just wanted to fire, why was Justin so angry with the popularity of Promise Kit versus Rack? That's probably for you, Justin, but Josh should probably answer too. No.
Promises are a subset of what observables and enumerables, I guess, can do. I guess more enumerables, actually. Promises are like a stream that's always limited to one value. And in general, I don't think that's super helpful. It's useful for like network requests where it's like, oh, yeah, kick off a thing, comes back with a thing, you're done. It's not as useful for button taps or for any kind of repetitious events or like recurring events. And so people that argue that they don't want to use streams or Reactive Cocoa or RX or whatever because they have promises, I think that's bunk. Like, that doesn't make sense to me. I think RX and Reactive Cocoa are a superset of that. But using promises within our interfaces, I think, can clarify intention and can make it, I don't know, it's useful for expressing a very certain kind of thing, which is something that returns one value in the future.
I'll also just say that I think one of the great things about Reactive Cocoa and about signals is that, in contrast to promises, and Justin kind of waved towards this, but it allows us to unify a lot of things that in Objective-C and in Swift are very different things. And it helps us to realize that they're not actually different things. Syntactically, they're different. Like a notification is a different thing from a delegate callback, which is a different thing from KVO, which is a different thing from a button tap. And we treat those things as being different things, but they're not. They're not different things. And Reactive Cocoa lets us see that, whereas promises are a very specific solution to a very specific problem. And that's fine, but it's not nearly as powerful, and it's not nearly as unifying as Reactive Cocoa signals are.
I think to sort of add to that is that for a lot of people, promises resonate better because where do you see asynchronous stuff? Network requests, right? There's not a lot of places where you look at button requests or button taps or UI application events or any other lifecycle events as something that you would wrap in a promise, I guess. So people, what they're used to, my speculation is that promises just are sort of a small answer to a small question, and again, they're narrow and they can do that for you, but you lose out on the unified approach.
While we're talking about alternatives or similar things out there, bolts, that's a thing. And Justin's looking at me already angry about it. What problems does Rack solve that bolts doesn't?
I mean, bolts is just promises. It's still just promises. But
it says bolts, Justin.
So bolts is actually based on .NET's task parallel library, which was introduced after reactive extensions in .NET and has kind of a similar relationship that Reactive Cocoa has with promises and Objective-C. So in Eric Meyer's talk, he used their task type to represent the promises in the enumeration thing that I was talking about. But it still suffers from all the same problems. Like, it can't represent any number of those disparate things that we really care about. Like, we want streams to be kind of the unifying paradigm of how we write stuff. Promises are just a tool. They don't really change what you can accomplish or do. They're just a slightly easier way to write asynchronous code, or excuse me, like asynchronous requests specifically, because you can't do much more.
I'd like to add, to be fair, that if anyone here thinks that Reactive Cocoa is too big of a step, then we might be saying signals and streams are better, but that doesn't mean that there's not a good reason to say step into it using promises. I wouldn't recommend it, but I don't want to say don't do it, because if that's best for you, then hey, so be it.
Oh yes, definitely. As has been mentioned, promises are a smaller answer for a smaller question. But if your program has small questions to answer, I mean, by all means, use the right tool for the job. Don't feel like you have to use signals just because Justin says so.
But hey, we're gonna have Rack Promise in Rack 3 now, right?
Yeah,
Isn't
right.
that, so we'll have it all.
They're officially cool now.
Yeah.
Justin said so.
Blessed.
Also, small questions, that almost sounds like it's insulting your app. It isn't at all. I just want to be clear.
No, sorry.
I'm actually going to give, does anyone in the audience have anything to add to this? Because I feel like there are a bunch of people around who are pretty big into bolts and promises who possibly have something to say. He's intimidating, I know. It's fine. All right, okay. It seems to be the trend that people are adding comments to the issue, but if you do want to ask the question yourself, do just raise your hand and we'll bring a mic over to you. Rob, do you want me to ask this, or do you want to ask this yourself? Me? All right. You have a microphone. It's true. It's true. It's given me terrifying power. So from this guy called Rob Ricks, who I hear programs computers, the enumerable/observable types seem to present a similar structure to iteratees, as defined by Oleg Kistyal. Is this a valid observation, or is there significant distinction present? Question. Will promise returning enumerables provide a good opportunity for Rack to capture I/O?
This is why you should have asked the question, Rob, because you wouldn't have butchered names like that.
I would have just said Oleg.
Yeah, I was thinking
Yeah.
about that. Hindsight's 2020.
We were talking about this a little bit during lunch, and it's interesting because iteratees, I feel like are maybe a more thorough answer than promises in some ways, and so it might be interesting to think about how we could use iteratees instead of promises. And it's kind of a similar problem that we had before, where expressing a complex type like iteratees in Objective-C would just be awful. It would be terrible. But with Swift, it may actually be reasonable for us to express something like that. And it may be a more thorough answer than promises.
Anything else? Or are you looking blank? All right. Does that answer your question, Rob?
The I/O thing?
Oh, yeah. Will promise returning enumerables provide a good opportunity for Rack to capture I/O?
I think so. I think that's a very natural representation, which is like you're enumerating over some input source, and you pull out things that represent future input that you're going to get from it. Yeah. Or, I mean, if it's a stream of input that's always open, then observable would be more appropriate. But if it's something that from which you want to pull, like a file, then enumerable is more appropriate.
You keep inhaling like you've got something to say, Josh.
I'm good.
You
I'm
good? All right. I like this question a lot. Kirk Shoop, which I hope I haven't butchered. This is good. I like it. Since promises cannot complete empty, how will an enumerable using promises signal completion?
So the key to this lies in the type signatures that I presented, which are not final, but I think hint at the direction I had in mind, which is that the promise would contain an event which represents the current types of things that can happen to a signal today. So you have next events, which are like they send a value, they send a value, they send a value, and then you have completed or error. So a signal can either complete normally and successfully, or it can terminate with an error, indicating that something went wrong. So if the promise contains an event type, then it'll say like, oh, you enumerated over a next value. Oh, you enumerated to completion. You trying to enumerate and you ran into a file reading error or something like that. So the key is putting all the error handling and completion stuff into the value that's contained within the promise instead of complicating the implementation of the promise class with that information.
Folks who have put questions on the issue thread, if something isn't clear or something like that, I can't really ask you. So if you want to add like further follow-ups on the issue thread, that's completely fine. Ideally quoting the part which you didn't get, so I know what it's related to. Because the trend seems to be more people who I think I can see in the room adding stuff in the issues. Okay, so this one from E. Patey. I'm pretty sure that's fine. One of the idioms that you've decided to deprecate in Rack 3.0 is the concept of multicasting or replaying. I understand this as multicasting has confused me. I'd love to hear a little more color on both the original motivation for the features as well as what led you to pull the plug. Is anyone like not really familiar with what multicasting was? Because I think that's probably.
Yeah, we can explain.
Yeah, I think it should be explained.
Yeah. So the really brief problem that multicasting is trying to solve touches on the problems that Justin's trying to solve. So if you have a cold signal, it means it's a signal which, when someone subscribes to it, it starts doing something. Like some work is done at that point when it is subscribed to. But the problem is that oftentimes you'll only want to do the work once, but you'll want to have multiple people who get the results of that work. And so the way that we handled that is through multicasting. And so multicasting basically said, go ahead and do the work once and then multicast the result out to all of these other people because these guys care too. Historically, multicasting came from reactive extensions. And so that was just kind of more or less a straight port of the ideas from RX to Objective-C. They have multicasting and they have all these different versions of it. And so that is historically why we had multicasting, and that's the problem that it's trying to solve.
Yeah, and so to put it in other terms, multicasting takes a cold signal and gives you a hot signal. Or excuse me. Well,
this is why it's getting removed.
Sorry. Yeah, it's actually.
He only wrote it. It's no big deal.
It's actually fairly unclear. But the problem is exactly what Josh described. You have side effects, and you want to share the values, the generated values, without sharing, or excuse me, repeating or recreating the side effects. So you don't want to make multiple network requests just to use the response from the network in multiple places. And so the way you would solve this in my proposal above would be to, let's say the network request is an enumerable, it does side effects when you pull values from it. What you would do is you would instead convert it to an observable, which multiple interested parties would attach to. And because their attachment doesn't create any additional side effects, the work is only done once, but it's still distributed out. It's pushed out to the observers that care about it. So basically, multicasting still exists. It's just represented in the type system, which is novel.
What does that conversion look like? Is the library going to do that, or are you going to, as the consumer?
The question was, what does that conversion look like? Is the library going to handle that for us, or does the consumer have to?
That would be a library feature. So it'd be like you have an enumerable. It's actually what I described before, although I didn't have a slide for it, is like if you have an enumerable, there might be a method which is like enumerate and send everything here to this observer, which you can then have any number of side effects or something. Or excuse me, any number of interested parties. I don't know where side effects came from.
Anyone from the floor with questions?
I'm not hearing a lot of the typical questions. Are
Yeah,
people
I was thinking that.
not wanting to talk about like the common questions, I guess?
Yes, fantastic. Yes, everyone cheer that man. Guys, do we have a microphone floating around, or am I going to have to repeat this one? I will run around. No, stupid questions are exactly what we want, because I've got a huge pile of them. Could you hold on 5 seconds while we get a microphone to you? I was so excited about this happening, we forgot to actually prepare for it. It's fine. Vamp. We'll now abuse David as he runs around the room. Okay, cool. Thank you for waiting. After I put so much stake in having a question from the floor. All right, I'll repeat it. It's no big deal. Smooth.
So with the previous way of doing multicasting, you can trigger the side effect and then subscribe later on, and the value will be shared. This is still possible, right? You won't trigger the side effects even though the subscription happens after the side effect happens.
Oh, do you want me to repeat it? What are you guys? So in multicasting, you could trigger the side effects, but then subscribe later on, right? Previously, and I guess the question is this still possible with the new API, right?
So the motivation for this in Rack 2.x would be you want, like network request is a common example, like you want to do the network request, start doing it before anyone's actually ready to receive the result, and then when they are, give them the result. Like fairly common pattern. I've kind of come to the point of view that that's bad, and what should actually happen is no work should be done until you know that someone's interested in it. And so what I would say is that there should be like your method that would encapsulate the network request should return an enumerable, and again, no work would be done until you try to pull stuff from that enumerable. And if you want to share the results, then you have to do the conversion to observable like I described. But the key is, I don't think there are actually any cases where you can't reorder things in a way that makes it clearer and makes more sense. I think multicasting and kind of this delayed subscription idea was really confusing.
Okay, so how would you solve, like, I'm in the splash screen of my app, I trigger some request, I want to pass it to the next big controller, but maybe there are multiple requests, so I don't know which one will finish first. So then maybe another big controller will get that same kind of request, the results of the request, etc. But I don't want the request to happen again. I just want to pass the result. Is this possible, basically?
I have no chance of repeating that. Do we have room mics?
I'm going to try to
just try
represent
and
that question accurately. So I guess you're asking if you kick off multiple requests. I'm sorry. Can you rephrase it?
I think I might be able to.
We got a mic.
I think I might have understood,
Okay.
but part of so were you saying in the view controller you're kicking off some request and then later on you're moving to some other view controller, but you still want that view controller to be able to get the result from that request?
Yeah.
Yeah. So I think in that case it's just restructuring your program using MVVM or some other restructuring where you're not hosting that request inside of the view controller and having to be responsible for passing it from one view controller to another. Instead, it gets kicked off, and then your subsequent view controllers have the ability to ask for that. And then in Rack 3, I don't know, with the new idea, I assume you would have to somehow have that as a promise that you would pass around, but I'll let Justin speak to that.
Yeah, so I guess, is this question coming from like typical MVC, where it's like your controller is responsible for your network requests?
I mean, I assume that the problem will still be there if it's the view model that triggers the response, the request, sorry, and then it has to be passed to a child view model or a child view controller?
Right, so the way I would tackle this particular problem is like have the originator create an enumerable that represents the request and then pass that down.
Okay.
So no work is actually begun until the party down the line indicates that they are interested and want that to begin.
Okay, now there's when the multiple requests at the same time comes in place, because maybe I triggered 3 requests. One of them is the one that blocking the transition to the new view controller, but I want the other 2 requests to be ready for the view controller when it presents also as fast as possible. So like kind of prefetching type of thing.
I mean, this is a problem I'd have to think about some more, but I think there's a reason that I used a promise type in my slides too, and this is one case where it might actually be very applicable, because you can start a promise and then it caches the result until you're ready to use it. But I have to think more about whether I actually want to encourage that. Okay. So I'll have to try out what you're suggesting and see if there's a different way to do it.
Yeah. Oh, sorry, Tim. Thanks.
Yes, I think this is part of a general class of questions we get asked a lot about Reactive Cocoa. It seems like with functions of treating streams of events and dealing with asynchronous work, it would be a great way to implement some kind of network request caching systems for your app, where network requests get cached and the cache gets invalidated from different parts of your app, but you still have a consistent view from all parts. And we never had a good answer for that. Sorry. Yeah. I don't know if we'll have in Rack 3.
What even is Rack 3 at the moment?
Yeah, I think this is a caching problem ultimately, like you alluded to, and we can maybe offer things to help with that, but that's also not really the problem we're trying to solve. So maybe there's something there, but I'm not sure what the right pattern would be yet.
Any more from the floor? Or follow-ups to that? No? Cool. If I can't see you and you're waving your hand, just shout. There's a small chance. Okay, so another from Rob Ricks. Reducers, enclosure, etc., and Swift's map/filter implementations compose the blocks they're parameterizing by sort of analogous to deforestation. Seems legit. Would this be a possible optimization for Rack versus building a graph of Rack signal instances, cutting down on the allocations and processing necessary?
It's an interesting idea. I don't really know. I mean, reducers are certainly a very interesting way of eliminating all of the intermediate steps that you would typically have to go through. Taking an approach like that with signals would be interesting. Yeah. Pull requests, welcome.
I'm mostly curious as to whether there's something I'm missing in terms of would that violate the monadic semantics?
Would that violate the monadic semantics? The monadic semantics? Yeah, monadic. Yeah.
I don't know. I would have to think about it a whole lot more. Yeah, I don't know.
2 I don't knows in a row. You guys are doing well. Could we get a microphone? Is it in the near vicinity? You broke it, Dave? Oh, okay. It's fixed now? Cool.
Yeah. So for an optimization like that, I guess you really need to start knowing about whether you care about the intermediate values that you're deleting. And I don't know if there's a good way to know that in the languages we're working with. You can't see the reference counts anymore. Yeah.
Yeah. And B1 would come after you.
It was just a comment.
No, that's fair. Anything else from the floor? No? Okay. So I want to stay with the topic of performance, actually, because there was a pull request not that long ago, which went through a bunch of stuff which we've been doing pretty slowly, to be fair, compared to what we could be doing. So I was wondering what you guys had to say on the topic of Rack's performance impact and optimizing it, or anything about that.
Yeah, where to start?
Yeah, right.
Like just lots of ideas floating around. I'm sure. Speaking for myself, there's been various ideas where you look at something that's potentially a problem, and you say, okay, what can you do to fix it?
But is it just premature optimization? I think that's personally my biggest question. It's like, is Rack ever really the bottleneck or the slow point?
I think for those of us at GitHub, I think it's really hard to get a feel for that, because almost all of the work that we've done is on the Mac app or on various Mac apps. And so we're not nearly as constrained as most of you guys probably are on iOS, in your iOS apps. Maybe you guys would have some comments on that, since you guys aren't iOS.
Yes, there still are some issues, especially when concerning memory churn, because the computation time is not very expensive, but the fact that so many objects, intermediate objects, and state gets captured and released and so on and so forth, that can be a problem on mobile devices.
I personally believe that this is kind of a two-part answer. The first is that good abstractions usually do impose some cost, and that's not to say that's a bad thing. It's just like sometimes in order to program at a higher level or a more declarative way, actually auto layout is a good example of this, although I personally don't like auto layout, but it's a good example of what I'm illustrating here, which is like...
Couldn't resist.
Yeah.
Had to slap it around the head, didn't you? That wasn't weird.
But no, auto layout is a good example because it allows you to program at a higher level, but it does have an associated performance impact in terms of the layout passes and solving constraints and all that stuff. But for most people and most applications, that is acceptable for the gain you have in being able to express yourself. I feel like Reactive Cocoa is very much the same way. And then follow on to that is most things in Reactive Cocoa, I don't think have to be bottlenecks. If there's a bottleneck, it's usually just because we haven't focused on it. And if anyone came to us with a problem, we would optimize it to where, like, it would be possible to optimize it further to where it's not a bottleneck for someone. So it's mostly, where we choose to focus our work. And if stuff seems like it's going okay for most people, we're probably not going to micro-optimize every single method call, but we could if that were an issue.
Before you guys jump in, I'd just like to say that there is a comment on this, which is from the thread, which is, for me, performance absolutely is an issue in table view cells with complex sets of signals, particularly big combined lattices. I have to defer subscription until the table view stops moving in many cases.
So table view cells, sorry to jump in, but table view cells are actually kind of a good example of what I'm talking about, because many uses of Rack that I've seen in table view cells have people creating subscriptions in things like, I don't know, prepare for reuse or layout subviews even, or whatever it may be. When, in my opinion, the correct way to do this is to set up all your subscriptions and your signals in the initializer, and then just ensure that things get properly invalidated or reset when the cell is reused. So never tearing down or creating new things upon reuse, but just making sure that it kind of flips to the new state correctly. And that's a bit hard to describe verbally, but there have been some historical issues on the Reactive Cocoa repo. If you search for them, like under closed, things tagged with the question label, where I kind of go into this in a bit more detail. But basically, like if you're ever disposing of something in a table view cell, it's probably not as fast as it could be.
To talk about table view cell, that is, yeah, a common error. And I think one of the things to consider also is just UI table views API, which has, a bunch of reload operators, right? So I think people, they get used to Reactive Cocoa and they want to bind everything. And so it's like, oh, here's my cell, I'm going to start binding things to it. But almost kind of like John's talk about having one piece of state that gets sent on a signal, how often do parts of your cell change but not other parts? So oftentimes I think an optimization is just to not be binding individual items in your cell, but instead just have react to a change in a cell that just has a subscriber that does the appropriate reload call to that cell at that index path. I have some comments generally about performance as well.
Go for it.
One of the areas that I've been thinking about but I haven't brought up, but I'll mention it here, is I feel like that there's, and it might relate to Rob's question as well with reducers, but I feel like there's potentially a lot of unexplored opportunity with how we do subscribers. So right now, subscribers are all signal operators are all subscribers upon subscribers, and I think that's where a lot of the churn comes from, and I think there's areas there where we completely, at least, from the outside, I don't know, there might have been internal talks, but where could be doing a lot better job sort of pruning or optimizing how, because every signal has its own synchronize, but does every signal need that, right? Or subscriber need that, right? You could sort of try to coalesce some of the locking, coalesce some of the block invocations, stuff like that.
I think this is a great reason to have an observer or subscriber interface and multiple concrete implementations that differ in behavior as well. So and the same thing for enumerators. But there's also kind of an open question of how Swift changes this footprint too. Like many of the common performance questions we've gotten to date, it might just completely shift the dynamic to other things. So who even knows?
Yeah, Swift had some really big bars.
Yeah, so I think 2x was one.
Yeah, very big.
It's a big bar. Or two times, if you say it properly.
I feel like on the performance aspect, we kind of painted ourselves into a corner by defining very strict evaluation semantics. So we have to respect side effects of every block you pass into the system. Every map filter has to be evaluated in that exact same order. All the blocks have to be serialized. You don't have to care about your blocks being called on different threads and so on. And if we could at some point relax those semantics, we could get away with a lot of more optimizations.
Yeah, I think that's a great point. I'm a big believer in safe by default, but the problem is we've had safe always so far, and maybe some way to unlock performance at the expense of safety would be beneficial.
3.0. I'd be interested to hear other people's thoughts on some of that stuff. If you want to dump them in the thread, or you have raise your hands or anything like that. But I'm going to divert the conversation for a second and talk a bit about tools, because I recently given a talk about Rack and MVVM, and at the end of the talk, I kind of barraged Apple for being really shit at making developer tools, which I felt a little bit awkward about yesterday. Because they actually came out with some pretty decent stuff. I'm thinking specifically around playgrounds and a lot of the visualizations and stuff like that. And some of the work that our colleague Marcus has done with RX Spy did make me, and like conversations we've had about like how awesome would it be, and now we've got this playground thing where you could like visualize a chain of signal operations and stuff like that. Are there any concrete plans or thoughts or anything like that about what we could be doing to improve the tooling we have at our disposal?
There's a long-standing issue open on this, I think. Isn't there?
Yeah, I think there is. It's one of those things that we would love to do, but it takes a lot of time, and it would take it would take a lot of time to make something actually polished and usable. The RX Spy thing that Danny was referring to is something that our coworker made, which allows you to kind of visualize what your signals are doing in your app, which would be fantastic for trying to understand how data flows through your app and trying to understand performance problems. And it would be fantastic, but it would take some time and a lot of work. So we just haven't done it.
We just need to write a quick look generator now, right? That's how that works.
Yeah.
This feels like a good one where maybe a matchup of sort of the right people at the right time where you hack on it. So if someone out there wants to work on something like that, some developer tools with Reactive Cocoa, I'd be happy to, I'm sure any of us would be happy to help out, but I volunteer myself to aid in something like that.
Yeah.
If you're looking for an excuse to use Swift, this is a good place to do it.
We have an arm raised at the back there.
Oh.
Do we have a microphone? Shall I just run over with this one? David's running over.
Why don't we have the Rocky music queued up?
Over here.
This way, Dave. Actually, yeah, Rob, do you want to be runner? Okay, cool.
Cool. So I have a little more far question, sort of around developer tools, and I pseudo mentioned this to a couple of you guys over Twitter. When I started getting into this stuff and really understanding the whole idea of reactive and chaining events and all that kind of thing, I started immediately visualizing. I'd previously done stuff in multimedia with like Shake and Quartz Composer and that kind of thing, and those. So it just seems like it'd play so well to eventually have some sort of node tool where you're like visually combining things together, and then maybe you step into a node and you edit some code or you edit like a transformation of a value. But just I don't know exactly what I'm asking, but have you guys sort of thought of anything around that or possible developer tools of the future that would take programming kind of to the next level?
Yeah, I think, Rob, did you want to say something about that?
Yeah, so this is actually something that I'm really interested in as well. I've been building an app for 14 years, something like that. That's trying to do something like Quartz Composer, but more aligned to computation than to Quartz Composer's generality, I guess. It's not based on Rack, but there's no reason it couldn't be. Like, it seems to me like this is definitely something that that deserves time and attention. I don't think it necessarily needs to be part of Rack itself. I think Rack enables it. It's like, I guess what I'm trying to say.
Yeah. Okay. No, I guess I didn't.
So one thing to consider is there are a lot of programming paradigms that have overlapping scopes. As you said, Quartz Composer and so on is an example of data flow programming. There's constraint programming that is also similar in a certain way with the data bindings and so on. And I think it's important to make sure where one ends and the other one starts. I speak from experience because I've implemented two-way data binding based on KVO and Rack, and it came out really bad because it's on the other side of the line. You don't have to step over the line. So in Rack 3, if we want to pursue pool-based streams more, we can look into it. But for now, I'd say our focus is more on push-based stream, and data flow is mostly pull-based. As in, for example, Quartz Composer just runs the frames, and every time it requests a frame, it goes back and asks for data from every block, whereas we're doing the opposite, basically.
Yeah, I would love to be able to create signal chains just by... I don't want to say the words drag and drop because everyone will kill me, but, just be able to at least debug stuff. There's the two questions. One is which trying to visualize, signal chaining would just be amazing because I find it's a lot easier to reason about our code when we're writing in this way, but it's not necessarily as easy to see and with our current tool set, like as it's working. And I think we kind of need to plug that gap. But it's always easier to say than than spend the time to do. The other interesting question, which I have around tooling, was yesterday there was an interesting thing that went up, which looked like stack traces might possibly not be useless. Which is kind of interesting. Do we know anything about that and how that's going to work with Reactive Cocoa?
I mean, I don't know anything in particular, just that they seem to be capturing asynchronous backtraces now. And so when you asynchronously call a block, you can actually see in the stack trace where it was enqueued. So you don't, when you do something asynchronous, you don't just lose the entire backtrace anymore. It's actually still there, which is fantastic.
Does anybody know if that's only for debugging, or if you'd be able to get a stack trace on a crash that had that full background? Anybody know? I didn't think so.
Does anyone know if that's only for NS operation queue or if it's for GCD as well? It works for GCD as well.
Yeah.
Okay, thank you.
Just rub some GCD on it. Fixes everything. Okay, so there's still a couple questions, but we've been sitting at this for quite a while. So I think we're going to take a bit of a break, 10 or 15 minutes or so, get up, stretch your legs, and we'll come back to this. Okay, so see you in a bit. We still live on the stream? I'm hot. Perfect. That's why Patrick's here. Okay, so we're actually going to focus on a bit more sort of beginnery stuff in this seating, because I feel like we've done a lot of advanced questions, but last time we did this was a lot more, well, I guess Rack was younger. There's a few more questions from folks new to Rack, and I'm going to try and channel that because I think that's equally as useful for some of this stuff. Before we get too much into that, I'd like to address getting started with Rack. Right, one of my biggest problems I had when Josh randomly wrote this thing over a weekend was that the barrier for entry is actually pretty high. Like you have to learn what these operators mean, like what's going on with all this, that, and the other. Are there any projects we're doing, or is there anything that we have in the back of our minds to help lower the barrier for entry for people coming from just Cocoa development?
So what would really help with this is if people stopped rewriting the framework every couple months, and we could start writing documentation that would remain valid for an extended period of time.
So I'm definitely hoping that Rack 3 is the stable one. But in all seriousness, I think the barrier to entry with Rack is mostly one of understanding and learning the stuff rather than starting to use it. So like it's once you have a basic understanding, I think it's pretty easy to start using incrementally without having to rewrite your whole project. Like you can use bits and pieces and really get a lot of benefit out of it. But the understanding is really the core issue, and this is actually exactly why I want to simplify the framework and really get it right, is because I think, there are a lot of people that have shown up, there are a lot of people that are really interested in using it, that have been using it, but it's going to be hard to really get real long-term traction unless it's much simpler. And even the people that like using it and do use it today, it's going to make their programs simpler and make things easier to reason about if the framework itself has simpler concepts as well. So I'm really trying to solve that problem, and then I do think we can start actually recruiting new users with good documentation materials and things like that. I mean, we have a lot of documentation, but it's not very beginner friendly.
I also kind of wonder if Swift is kind of a reset the clock on that. Like with Swift, we're all going to be learning all of this new stuff for the first time together anyways. And it's not even clear what best practices are with Swift or what patterns make sense in Swift. So, I mean, Reactive Cocoa kind of has this chance to be part of that, to say, look, you're learning Swift and that's awesome. Now check out like Reactive Swift, which adds all this other cool stuff on top of it. So I think there's a really interesting opportunity there to kind of be part of this brand new thing.
And going back to what we said earlier too, like the map and filter and what have you on the Swift collections as they exist today also reduces, kind of on its own reduces the barrier to entry with Rack, because you'll be much more familiar with those operators and what it all means before we start talking about asynchrony.
That's somewhat in the future, and we're talking about the framework. I was actually kind of expecting answers more around docs and tutorials and things like that. And I guess the one of the most common questions I get asked is, where does one go? Like now to start learning about Rack? And my own question on top of that is, where should they in the future? Like, where do we want to introduce people to the framework and how?
The README is the canonical source for that, and it actually has a list of resources that answer exactly this question. It's like, hey, first start by reading this, and then go check out this, and then check out this, and then check out the Q&A that we do sometimes, and stuff like that. So I think there's kind of there's a little bit of a treasure map aspect there, or like scavenger hunt. So we have a lot of work to do in collecting that documentation in one place and making it really accessible, but it does exist.
I feel...
Oh, Wolf.
Yeah. So what do you think of maybe steering that has
that was fast.
Record time.
That was totally worth it.
Rob Ricks out of nowhere.
Yeah. Yeah.
What do you think of the concept of maybe steering people towards Elm? Because it's you know, Cocoa has its own way of doing things, its own center of gravity, its own obviously highly imperative, all that. And Elm is a smaller playground that that all the sample code and all the ideas are geared towards what exactly what functional reactive programming is. And it's a very playgroundy. I mean, it has a different connotation now, but I mean, it's highly interactive environment. So could this be it's not really training wheels, because it's really a wholly separate environment, but at least dramatically reduce scope to get people up to speed?
That's a lot of sighing.
Are you so when you say going to Elm, do you mean their documentation or their sample apps? Because they have sort of like that playgroundy type thing where you can see like live. They have sort of these sample apps that help you learn.
Yeah. I was thinking steer people saying, if you've never heard a functional reactive programming before, like maybe you shouldn't start with Reactive Cocoa. Like, look at this demo app in Elm. Go check this out and play around with that first. So it's because of the smaller scope, and that would then once they get something working, once they get a demo working there, then you're like, okay, now you can have your brain blown if you know how to code Cocoa.
Can we just do sample apps then, just like theirs? Port them if
Sure. I mean, it could, but it's a lot more concepts that are being intermingled at the same time. Especially if you have a Cocoa background, it's almost as if that's a hindrance, because you know how things should be done in Cocoa. Right. But in Elm, it's like new language, new set of technologies, and you just have that clean slate effect.
We could probably do this in Swift as well.
That's a really good point.
Yeah, I was wondering whether that becomes that.
Yeah, just have blocks of code you copy and paste into the playground.
But it's not just a pure language thing. It's also how you structure your Cocoa app, and that doesn't change in Swift.
Yeah, so I think the danger with Elm, it's kind of this constant tension between ease, being familiarity, and simplicity. Elm is extremely simple, and it's amazing for that reason. It's great. But coming from a Cocoa background, you're going to have a really hard, in my opinion, uphill battle learning how to use Elm. And although that knowledge may then help you learn Reactive Cocoa, which I think is the thesis of your question, I'm not convinced that that's actually easier than just trying to iteratively or incrementally get into Reactive Cocoa itself. So I think it kind of depends on the person, actually.
Okay.
As to whether seeing it out of context is more helpful than seeing small pieces in context.
Also language. Like the interesting thing for me is like when seeing like Ruby programmers' reaction to Ruby Motion was kind of fascinating to me. It's like they still had to learn this framework and this new way of doing things, but just because it kind of looked somewhat familiar to what they do every day, it was appealing to them. And therefore I wonder, forcing that fresh start on people, we're saying Elm, like whether that will freak people out more rather than us at least pointing to a language which looks somewhat familiar to them.
That's a good point.
And saying, oh, actually you just have to learn these different concepts.
I would almost say that so a lot of the aspects of Elm that you're alluding to, like the statelessness and kind of the like higher order functional programming and stuff like that, I think it's almost like a lot of that is emergent once you start using more and more Reactive Cocoa. And so when you're starting out, I think it's totally okay and actually great to have just like, oh, I want to observe this thing and then do some side effects. And kind of work your way in through that. And then eventually you can be like, oh, well, now I want to try to avoid side effects to make my code easier to understand. But you can still get that basic initial benefit of like, oh, this handles asynchronous stuff really well for me. And then kind of work your way up from there and kind of go up the ladder of abstraction a bit.
Yeah, one challenge in particular we have met many times when trying to teach or get Reactive Cocoa to be more accessible is that like 90% of the benefits you get is when you start to scale up. When you start to get more complicated problems, when you start expanding your architecture to compose with signals and so on. And it's really hard because it's easy to show the basic building blocks with Hello World applications or watch something change and print something out to the console, but it's very hard to make self-contained examples of complex structures.
Yeah, and so there's one of my favorite formats is like code sample Q&A, which is really hard to scale, and unfortunately I think it's been harder for us to respond as quickly as we used to. But I really like this format because it's like people come with a problem. It's like, here's how I typically do this thing, or here's what I tried in Reactive Cocoa. What's the ideal way to write this? And I think each person learns differently, but through enough of that kind of back and forth discussion, you can start to kind of put together your own mental picture of what Reactive Cocoa is and the right way to use it. And it kind of there's just a point at which it clicks. Like, there's a big analogy here with monad tutorials for anyone who's ever tried to learn what a monad is. It's like every person who writes a tutorial about monads writes it based on the thing they heard last that made it click for them. But there's really a whole bunch of like built up stuff. It's like you have to learn all these different pieces of it to really get the full sense of the definition. And then it's like, oh, the person that last heard it compared to a burrito is going to write a tutorial about how monads are burritos. But that's not actually the case. You just have to have that kind of repeated exposure, I think, is really the key.
That's monads, Justin. Entirely different.
Can I add in a few points there?
No.
I think.
Yes. Yeah.
So to talk about a few things. That one, I once said that trivial example is considered harmful because, so talking about a simple signal and a simple subscription, a lot of people look at that and think, oh, I can just do that with a callback block. And I mean, that's kind of what it looks like.
There was that guy who did that, right? He wrote like an entire repository of like one-line examples proving that rack was useless or something.
He basically blockified everything.
Which was so weird.
And made composition through blocks, which sucks. But so I think it's hard because, again, alluding to what Justin was saying, it takes a path. You can't just sort of look at the README and feel like you get it. You have to experience it and you have to travel that path. And that path also, for me at least, and I think probably it's true for others, is it goes through different things. So you can't just look at the README. You can't just look at the concepts document that we have. For me, it was looking at some people's slides and asking a lot of questions. And I think that's probably, for me, the number one way to, and Justin also said that, put some code in an issue and ask, how do I make this better? Here's what I struggled with, here's here's the constraints. I think that's really the best way to learn at this point. But yeah, it takes so many different ways to come to that conclusion.
I have a couple points to that specifically though. Oh, there's a question. Go for it.
So, sorry, just before we get to that, just speaking to Justin's comment about code sample Q&A, I'm in somewhat of a unique position in that I have the privilege of working with Justin and Josh on GitHub for Mac, and so I always have access to them to ask stupid Rack questions, which happens a lot. The code sample Q&A stuff is actually really, really valuable in the sense of in the ways that Justin described. It was extremely valuable for me familiarizing myself with Rack, and I suspect that this is something that increasingly the community will be able to do for one another instead of simply requiring or always relying on 4 maintainers or however many maintainers there are. I feel like this is something that we are increasingly, hopefully, going to see a network effect with. But yeah, mentors work.
Yeah, ask questions and then become the person who answers questions.
This is intimidating, though. I need to point that out. Like, not everyone is at the disposition to have their code critiqued in public. Like, that is quite an intimidating thing.
Yeah, so the trick for me was just being naive and ignorant. So just ask and not be worried about it. I don't know. I'm sure I had lots of questions and comments that were, in hindsight, oh, that's kind of dumb to say. But I mean, that's that thing. Everybody goes through I have this dumb question to ask, but then you're smarter for it and you can help answer someone else's dumb question.
So kind of getting back to what Wolf was talking about with the Elm playground kind of thing, RxJS has actually put together a website that walks you through kind of composing different reactive pieces and has you like implement filter on your own, which is a really cool way of kind of learning what's actually happening under the hood with the code that you're writing. For me, that was kind of the big part of learning what Reactive Cocoa was you have to figure out what it's actually doing under the hood. So I think seeing more pieces like that would be awesome. I think playgrounds, Xcode playgrounds will definitely help with that. But yeah, so that's just my 2 cents.
I'm really glad you pointed that out, actually. The RxJS example is really, really quite nifty. I think honestly, it's something we have to get better at. I think it's actually kind of harsh just to expect everyone to just like throw up their code, because it's kind of a nerve-wracking thing. There was talk on an issue thread about this concept of a Rack My Ride blog post series, which I think would be excellent. But I think that like who wants to write it? we need to find the time, right?
Yeah, I think there's people who would volunteer to write the how to convert it, but there's also I think nobody's said, hey, I have code, I really want to be a part of this, like I'll give you my code and you guys do what you do. I don't know. So that's kind of a implicit solicitation. Anybody got some code, let us know.
Oh yeah, I should say that is still, like, whether it becomes a blog series or not, that is still completely valid. Like, throw up your code samples or questions or anything you have on the as an issue on Reactive Cocoa. Like, we welcome that because those guys get to answer it. I'm not going to do anything, but like they do get answered, and also Stack Overflow too, I believe, is also good. A couple questions in the audience. Rob, if you would care to run around. Thank you. Sorry. We'll come to you afterwards in the front.
So I actually have another comment about learning Rack. Is that some of the operators which really are very simple in concept, like map or filter, and you think should be simple to understand, when you go and look at the Reactive Cocoa source code, because they're based on lower level concepts which most people I think aren't familiar with, you can take a long time to wrap your head around why is it implemented this way, why are there all these complications which I don't expect to exist in the code. And although I think it's nice to base things on your simple low-level structures, maybe it would improve the ability for people coming into this, because what I do when I want to understand what something does in an open source project, I just go and look at the source code, is to make the source code for some of the most commonly used things as simple as it possibly can be. So you can look at it and go, ah, yes, I can see what that does, rather than I'm going to have to spend the next 15 minutes staring at this code before I really grok it.
That does run into our performance concerns, though. You try and make the most commonly used things simple or high level, and then that removes a lot of optimization possibilities, I guess. Although, Justin, did you have something to say to that?
So the hard part with that is you don't. So like, if we have enumerable and observable, for instance, and they both have map, you don't want to write bugs, or you want the implementations to be the same because you don't want to write accidentally implement bugs in one or the other or both. But maybe like a pedagogical example, like just here, let's start implementing Reactive Cocoa from scratch, and here's how we would implement map if we did it without monads and stuff like that. Like that might be helpful. I could definitely see the value in that. And then also, just wanted to say, flatten map is really confusing, and it's probably one of the operators you're alluding to because it's monadic bind. But I would be in favor of changing that to map and join.
I think we got to do that. I think everybody's on board with that. I think you're the last one on board with that.
Okay. Yeah.
Well, I don't, not as a dig or anything.
No, but I mean,
we had another question in the audience.
Sorry.
Okay. So one of the things that I thought might be like beneficial for learning this is coming up with a not simple but not complex contrived example of like a conventional app. And I don't mean like develop a fully, API featured like Twitter client or something like that, but something like Ashfurrow's, what was it, functional reactive pixels or something like that, but not reactive, and much, much simpler than that. Because if you like go to look at it, you don't know which file to look at because there are lots of classes. And something that was like a couple of classes that you could take and using a step-by-step guide, try and convert it to Rack, and then posting what you did on the issues repository, and from that, you could come up with try and learn, and then try and derive some of the higher level lessons, and also after a few people did it, you could see the pitfalls that were already pointed out. So it solves a lot of the recurring question kind of issue.
I like that idea a lot. We actually have your grocery list application. Is that still up to date?
I mean, it uses Rack 3. It's not great for learning Rack, no.
Of course it does.
But I wanted to say, one discussion we've had in the past is about having an example application that starts off completely imperative and typical and MVC and everything, and basically somehow creating a timeline of refactoring that to be more and more Reactive Cocoa, whether that's like just through commit history or something interesting like that. But it's come up. It's a little tricky to implement, but we're interested.
Sorry, I'm just stomping all over you. I should say, if you're sort of recently new to Rack or you're learning Rack, or whatever, and you've hit a wall or anything like that, or you've found something tricky or unclear in like your path to learning it, do bring it up like now, now or on the repo. And this is kind of what we're discussing right now, and I think it's super helpful. And there is. Are you just running around for the sake of it, Rob, or is that okay? All right.
Thanks.
Yeah.
I was wondering if I'm fairly new to Reactive Cocoa, a few months, so I've definitely started with 2.0 or whatever. So I wasn't a Rack user when we upgraded from 1 to 2. My question is if you have considered anything like canary releases or something like that, or like beta versions. I know that we can always use the branch, the 3.0, but at some point say, okay, this is maybe not 3.0, but it's stable enough, so we can release it to people and see if listen to their feedback, because but that's basically the question.
Yeah, we did something very similar with 2.0. We had release candidates. We went through like 6 of them before we actually tagged 2.0 officially, and it was very much for that reason.
I'll also just say that in the case of going from Rack 1 to 2, it really wasn't until we switched GitHub for Mac over to 2 that we kind of found problems and realized some things weren't great. And I expect that will happen whenever 3.0 kind of finally stabilizes, then we will switch GitHub for Mac to Reactive Cocoa 3, and at that point we'll have a much better sense of like yes, this is really close, or, oh, we shouldn't do this, we really messed this up.
Yeah, another indicator that we used last time is we merged the development branch in once we felt like we were far enough along that things wouldn't be significantly breaking from that point on. And so it's kind of like, at that point, there's no turning back. Is why we did the merge, and it's like, committing to getting the dot release out soon, or excuse me, the major release out soon.
Did you, Rob, you leapt over something, looking excited. Did that mean someone has a...
I was trying to find it out. I was looking around.
Oh, you had such purpose. I thought. So something that you said earlier, Dave, was super interesting to me, which is you said that learning Rack is a journey. It was journey or traveling or something like the word journey stuck to me. It's stuck with me, which was, it almost implied that it was like this fixed length of time or amount of effort which everyone has to go down. And I kind of don't want to think that that's true. I don't know whether I agree with you or not, because it hurts me, but are there significant things that we can do to shorten said journey? I think that's really the...
Yeah, well, for me, part of that was that I was interested in understanding, and this alludes to James's question there, is I was interested in understanding the internals as well, implementation details. So yeah, other people wouldn't necessarily want that. But I think because we are talking about a paradigm here, I don't know. I don't know how you could possibly have it so that there isn't at least some journey. I mean, sure, we definitely want to minimize it, and I think that's kind of what a lot of these questions are. How do you learn it faster? But you do have to, something has to click, right? Just like, again, monadic tutorials, Justin talked about, oh, you read a few of them and then you finally, something clicks. So we just got to get that click earlier. But I think it's always going to be kind of maybe like a harsh reality that most of the people getting started with Reactive Cocoa will be like self-started and self-interested in it, which, I don't want to make assumptions, but I feel like that describes most of the crowd that showed up today. And that's not, I don't even know that that's a problem to surmount, because if people don't find it interesting or valuable, then there's no harm done by them not using it. And so I guess coming back around to the journey thing, I think there will always be a journey, but I think it's the people interested in it that start upon it and, kind of understand that will be at least a little bit the case.
There's one thing to consider is many people starting off with Rack will come from a Cocoa brand, like vanilla Cocoa brand background. So they won't have much exposure to functional programming, working with higher order functions or view models, and all these patterns we've brought into Reactive Cocoa from many different places. Yeah. So depending on your background, if your background is more diverse, you will find it much easier to start using it. And now with, it keeps coming up, but now with Swift, one, because everyone's starting at the same level, and second, because a lot of these kind of patterns will emerge because they're part of the base library. It's going to be easier to start using.
Yeah, I don't think we'll ever want to get into a position where we're trying to, we don't want every Cocoa programmer to use Reactive Cocoa, because a lot of them would just hate to do so. And that's regardless of how good we make the framework, how simple we make everything. It's just not going to be appealing to some people, and that's okay. I think we have to be okay with that.
Yeah, I guess it's kind of like the earlier point about small answers for small problems. If you don't want to see, if you don't want a thing that unifies everything.
Red pill or blue pill?
What's that?
Red pill or blue pill?
Yeah, sure. If you don't want to see a unified thing, then you don't need to.
Yeah, cool. Before I move on the subject, move the subject on, are there any other questions about getting started with Rack or learning or things we could do to improve it? No? Was there one in the back there? No? If you do have any questions or anything, still do file them on the repo. Justin is not nearly as angry as he seems here. He's nicer on the internet. So we're gonna it's not the I'm trying to be, I'm gonna try we're gonna wrap things up in a minute, but I'm gonna spend a couple of seconds to talk about 3.0, but more specifically not what's going to be in it, but how we're going to move to it, because I think a lot of folks have not really been through a transition or know what to expect. Like, how are we handling backwards compatibility? What can people expect as it transitions? Like, it's been touched on, but is there a solid process of how that's going to happen?
Well, we had a game plan before Swift happened, which was we would preserve 100% backwards, or like 99% backwards compatibility. So all your old code should still work as intended. I think Swift complicates that question because backwards compatibility is a complicated question now, just on its own. I don't know. I would like to explore kind of what I talked about before, which is maybe we could just build something new in Swift and figure out a way to bridge the two, so you can still use the old interfaces in Objective-C, your existing Objective-C code, which you probably don't want to migrate over to Swift in the next year. I don't even know. And then, new modules that are written in Swift and that want to take advantage of these new Reactive Cocoa features can do so without hurting the old or requiring everything to come into the new.
So I have a related question. If someone were starting to use Reactive Cocoa now, like right now, which version and which kind of classes would you suggest they use?
It's almost like you were looking at the issue thread. That was one of the questions. Carry on.
I mean, it's always been the case that you should always use the latest stable release. I think that's still true. But I think if you pick it up today, you're going to have to anticipate some churn with 3.0 as it comes down the pipe. And there's not really a good way to avoid that. Like, I think, again, going back to what we were talking about before, we do want to stabilize the API, but we're still figuring out some big, hard questions. I think, nonetheless, if you want to pick up Rack for the first time with a 2.x release, you'll still, most of the things you learn will still be applicable. They'll just go by different names, or the APIs will be, I don't know, kind of like convoluted from one to another.
It'll be this, guys. That's it. That's all it is.
It's like a four-dimensional. You'll end up with a lot of knowledge that will help you in whatever next API comes down the pipe. It'll just look very different at that point.
The other thing I would add is just if you take a look, in the 3.0 development branch, there's a changelog. And that can help guide some of your decisions that you might make with Reactive Cocoa 2, because there's things that you can just start to do now, right? You can start to avoid using multicast connections and just use a subject instead. And the changelog tells how you do that. Here's how the code would look before, here's how it looks now. So there's certain things that you can do. Avoiding replay is another one that you can do now, and it will pay off in that you have less to convert.
Yeah, I'll just say as a general guideline, if something exists both in Rack 2 and Rack 3, then it's pretty safe to use. If it exists in Rack 2 and not in Rack 3, there's a reason why we took it out, so try not to use it. And if it only exists in Rack 3, we still don't know if it's a good idea to add, so don't use that either.
Yeah, I do want to caution people about the changelog. I think it can be a helpful resource, but I would not treat it as an absolute truth. I think it's very much what Uri said, which is you can understand why we made some decisions, and those motivations will still remain, but they might take a different form, a different concrete API form in 3.0 as we keep working on it.
Cool. Before we wrap it up, were there any other questions from the audience? I think we've answered everyone on the thread. No? Fantastic. Then all that remains is for me to say thanks, guys, firstly on this, and thanks, everyone, for coming. There is yet more food. We're apparently trying to fatten you up or something. Out there, you're more than welcome to hang out at the GitHub offices for, I don't know, when are we going to kick people out? For the foreseeable future. I'm sure you've got parties and things to go to at some point. But that's us for today. We're done. Thank you very much for coming.